So, what are loops? This is going to be a new topic that we are going to discuss. So, you might be getting a lot of questions in your mind that what are loops? Why do we even use it? So, a lot of times we have to do things repeatedly, not only in programming, but let's say in real life also, we have to do things repeatedly. For example, let's consider the example of a bank. Let's consider the example of a bank. In a bank, there is a cashier, right? Different person come in a queue and try to deposit the cash to the cashier. Now, if you see it with the perspective of a cashier, they have to do the same thing again and again. Like they have to collect the cash, count the cash, give them a receipt. Collect the cash, count the cash, give them a receipt. Collect the cash, count the cash, and give them a receipt. Can I say that? So you have to do things again and again. And this can happen a lot of times, right? This thing can happen a lot of times. So whenever we have to do things repeatedly, whenever we have to do the same task that we did once again and again, in that case, in that case, loops actually help us. Now let's talk about with respect to programming. In programming also, we might have to do things repeatedly, right? I'll give you examples where we might have to do things repeatedly. In those cases, loops help us very much. Okay. Currently, we have talked already discussed about conditionals, right? So everyone already knows about conditionals, right? That using conditionals, we were able to make decisions. Similar to conditionals, we have one more construct. We have one more fundamental foundational construct called as loops, right? And using loops, the best part is that you will be able to repeat something that you have already done once, right? So let me write about it. Using loops, we will be able to we will be able to repeat a task again and again, again and again. Okay, again and again. So let's take a problem. Let's take a basic problem in hand. And with that problem, we will try to actually understand this basic foundational programming construct, right? With this problem, we will be able to clear most of our things, right? And it will actually help us in a lot of sense in actually understanding how exactly loops works. But I hope the basic definition of loops, that what are loops, is clear to everyone. Now let's take a problem in hand and actually see what are loops and why do we even need it. So let me give you guys a question. Let me give you guys a question. One second. So one moment. Let's say the problem says that write a program, write a program to print the numbers from 1 to 10. Okay. Let's say I ask you to write a program, let's say write a basic program to print all the numbers from 1 to 10. Let's say I take this example and I ask you that whatever knowledge of programming you are already having, try to write a program out of it. So currently we have discussed basic things like variables, conditionals, basic printing statement, right? So currently with your current knowledge, the most relevant code that you can write is this. So you can write something like console.log 1, console.log 2, console.log 3, and so on and so forth. At the last, console.log 10. Can I say that? That with your current knowledge of programming, if I ask you to write things from 1 to 10, like if I ask you to print the numbers from 1 to 10, you are going to write this console.log statement 10 times, right? 10 times we have to write console.log with different values. With different values. Can I say that? Right? 10 times we have to write console.log with different values. Now, if you see, there is an element of repetition. What is the element of repetition? If I ask you that, in this whole situation, what thing is getting repeated? What are you actually repeating? Then I can say the element of repetition is printing a number, printing a number, and then moving to the next number. Right? Printing the number and moving to the next number. This is the element of repetition. Can I say that? Because every time we are actually printing a number, every time we just print a number and then we try to move to the next number. Then we repeat the same thing. Print the number and move to the next number. Print the number and move to the next number. This is the element of repetition. Now, just think about it. Instead of 1 to 10, I ask you to print all the numbers from 1 to 1000. Do you think it is feasible to write a code like this? Like you write 1,000 lines of code and just do printing. Do you think it is going to be feasible for anyone? No. That means we have to find something better. We have to find a solution that can help us in some better situation, that can help us to do things in a better way. What can we do here? Let's talk about that. So if the problem scales itself, from 1 to 1000, or let's say even 1 to 10 raised to the power 5, something this big, how about if I say that you can write a code in like 3 4 lines and up to whatever limit you want to print you can print, because you got the element of repetition here. The moment you saw the element of repetition, you can do it with any limit. How about if I say that? So so let's say, let's try to figure out step by step that if we have to do this thing smartly, if I have to do this thing smartly, step by step, what I have to do actually. Let's talk about that. Okay. So what I can do is initially, let's say we will initialize a variable. Let I is equals to 1. Okay. Here we are going to initialize a variable. Initialize a variable. Okay. You might think that why we are initializing the variable. Don't worry. In a moment you will realize. The moment you initialized a variable, the moment you initialize a variable, the first thing that we have to do is print the variable, right? What is the element of repetition? Print a number and move to the next number. So I already have my first number. I am already having my first number with me. Like I don't care about the rest of the numbers. Let's at least print this number. Let's at least print this number. So what I can say is, let's say I will say console.log I. That is, I am having my first number. Let's at least print our first number because we don't care about the rest of the numbers because we currently don't know how to move to the next numbers. So let's at least print this one and let's then figure out what can be done, right? So now we have printed technically 1. The variable I, which is having the value 1, I have printed it. So your code flow like had a flow from this point to this point. So your code starting from this block and it went to this block. Okay. Now, what was the element of repetition? The element of repetition was print a number, that we did, and move to the next number. So I've printed I. How can I move to the next number? If I is 1, the next number to be printed is 2, right? So I can increment I by 1, right? So what I can do is, I can say, I can say, I plus equals to 1. Why we are doing this? Why we are doing this? Moving to the next number, right? We are moving to the next number, and here we are printing the current number, right? Now if we are going to write our code in a naive way, then technically now I became 2, right? This point I was 1, then we printed 1, and now here I is 2. So if we move in a naive way, we might have to do a console.log again, right? We might have to do a console.log I again, so that 2 gets printed, then we again do I plus equals to 1, and then 3 gets printed, and so on and so forth, right? But we are not going to move ahead with a naive way. How about using some construct, if anyhow any cost, if anyhow any cost, I can come back, I can come back to this position, right? Not to this, but like let's say this is our block A, this is block B, this is block C. So I don't want to come back to block A. No, I want to come back to a situation which was after block A and before block B. That is before actually printing I. How about if somehow my program again comes back here? If somehow my program again comes back here, right? So see, if my program again comes back here, then what will happen? What will happen? Here I became 2, right? And now we go back here. So if we go back here, you are going to print 2 because console.log I, and then we are going to move ahead again with I plus equals to 1, and this time I becomes 3. Let me repeat. Let me repeat. So initially, what we were doing, I have to write a program to print everything from 1 to 10, basic thing. So with whatever knowledge you have, you can print 1, then you can print 2, you can print 3, so on and so forth. You can print up to 10, right? But what if I ask you to print up till 10 raised to the power 5? It's going to be a mess, right? You can't print everything up till 10 raised to the power 5, because one by one you have to like write 10 raised to the power 5 lines. It's going to be something that you can't do again in one go. So we need something smart. We need a smart way. Okay, we need a smart way. So what smart way I'm talking about? So let's say I say that let's try to figure out a way in which we can do this thing smartly. How can we do it smartly? I say that let's initialize a variable I. You might think that why we are initializing a variable I? I'm saying that you have to print from 1 to 10. Let's store 1 in a variable, and then we can print that variable. You will see the use case of this variable later. So here I initialized a variable I. It's simple, right? I'll write let I is equals to 1. Can I say that? I will initialize a variable. See, I have initialized a variable. Now, if I want to print everything from 1 to 10, the value 1 is stored inside this variable I. It is already present inside the variable I. And what is our task? We have to print everything from 1 to 10, right? So I already have my first value. And what was the element of repetition? The element of repetition was, if you see this piece of code, then you print a number and then move to the next number. That means you print 1 and you move to 2. Then you print 2 and you move to 3. So on and so forth. So you will initialize a variable I. You can name this variable anything. You can name this I, you can name this X, doesn't matter. Variable naming doesn't matter to us for the time being. So you can say it as I, you can say it as X, you can say it as Y, anything. You can name this variable anything. We are just demonstrating a situation, okay? So we will initialize a variable I, okay? Now we have our first number inside the variable I. We have our first number inside the variable I. Now, I already have my first number with me. How about I just print it? Because I don't know how to move to the next numbers currently. Let's at least print 1, because at least we'll be having 1 on the screen. We'll be left with 9 more numbers. So let's at least print 1. So in the next step, I print 1. In the next step, I print 1. That is, I print I, which is 1. So if I draw a console here, let's say I draw a console here, your console window. So technically on the console, I have printed 1. right? I printed 1. And now, what was the element of repetition? You have to print a number and then move to the next number. How can you move to the next number? If you have I is equals to 1, the next number that we have to print is 2. So from 1 to 2, how can you move? I can add plus 1 to this. If I do I is equals to I plus 1, then I will become 2, right? Initially I is 1. If I add 1 to it, so 1 plus 1 will become 2. And can I say this is an assignment operator, which is a shorthand for I is equals to I plus 1. So after printing I will increment myself for I plus equals to 1. That is, I will increment myself. So I am done with the element of repetition. See, print a number and move to the next number. Now somehow I have to come back at this position. Somehow I have to come back at this position. Why? Because if you will keep on doing console.log and then I plus equals to 1, then console.log I plus equal to 1, it's not going to help. It's same as writing this code. But we want to do something smart. If anyhow, from here, I can come back to this position, right? So you start with I is equals to 1, you print I is equals to 1, then you move I to 2, so I becomes 2, and then you move ahead, at this position. Then maybe something can help us, right? Something can help us. So let's see. Let's start again. So initially, you did I is equals to 1, the value of I is 1. Can I say that? So from this box, you are going to print I is equals to 1, console.log I. So 1 got printed. Then you move to the next box, I plus equals to 1. That means you are going to increment I by 1. So I becomes 2. And then what is the next box? The next box is you're going to come back here, and technically you're going to go back here, because if you come here, then this arrow is positioning to this. So it says print I, console.log I. What is the value of I? What is the value of I? The value of I is 2. The value of I is 2. The value of I is 2. You move ahead. You printed 2 and then you do I plus equals to 1. That means you increment I again. I becomes 3. I becomes 3. The moment I becomes 3, again you are going to go back. Again you are going to go back to this block and you print 3. So you print 3. The moment you print 3, you are going to again increment I to 4. 3 plus 1 is 4. And then you go back here and print 4. And so on and so forth. And you will keep on printing like this. So technically speaking, we have automated, or technically we have repeated our task. This was our task. Print a number and move to the next number. I am repeating this again and again. So technically, we have somehow got a sense of loops. That is, you do your task again and again. But there is a problem here. When it will stop, like it is going to go infinite. 4, 5, 6, 7, 8, 9. It's going to go forever. Because you always increment and print. So this is going to go for an infinite situation. Can I say? The above diagram will run infinitely. Right? We need to somehow think about a situation or a tool using which we can stop this whole looping process at some point of time. We need to set up a mechanism using which we can stop this looping process at any point of time where we want, because currently it is going to go infinite. How can we do that? Now, how to stop this situation? How to stop this infinite process, infinite running instruction? Right? How to stop this infinite running instruction? The problem is this instruction goes again and again, it never stops. But what do we want? If I want to print numbers from 1 to 10, I want to stop this process the moment I becomes something more than 10. The moment I becomes something more than 10, I want to stop it. In the previous question, the moment I becomes greater than 10, we want to stop it. We want to stop it, right? So technically we have to take a decision, right? We have to take a decision that what is the value of I? Is the value of I greater than 10? If the value of I is greater than 10, then maybe just stop it, right? So technically we have to take a decision. Technically we have to take a decision. And how do we take decisions? How do we take decisions? We take decisions using conditionals, right? We take decisions using conditionals. So if I just cut this diagram from here, if I just cut this diagram, and let's move things a bit, and let's say I put a condition here. Generally I put this condition using this diamond, right? I say, is I less than or equal to 10? If I is less than or equal to 10, you will say a yes. Otherwise, you will say a no. Right? And how about we loop back instead of, like previously we were looping back at this position. How about you loop back at this position, or like to properly demonstrate, how about you loop back to this position, right? That you loop back to this position. Now let's see what happens. You initialized I is equals to 1. You initialized I is equals to 1. You move here. Is I less than or equal to 10? Is this value less than or equal to 10? Yes, it is. Yes, it is. So you print it. So you printed 1. And then you incremented I by 1. So now I becomes 2. I becomes 2. And then you go back. And then you go back and check again. Is the value of I less than equal to 10? Is the value 2 less than or equal to 10? Yes, it is. Yes, it is. So you print 2. And then you increment I by 1 again. So you incremented I to 3. Then you go back. Is the value 3 less than equal to 10? Yes, it is. So you print 3, because you come here and print 3. And then you increment I by 1. You make I equals to 4. And so on and so forth. You will keep on doing this. You will keep on doing this. You will keep on doing this. Let's say the value of I became 9. Is 9 less than equal to 10? Yes, 9 is less than equal to 10. So you print 9. You print 9. You increment 9 plus 1. So I becomes 10. Is 10 less than or equal to 10? True. Yes, it is less than or equal to 10. So you print 10. And you increment I again. I becomes 11. Moment of truth. Is 11 less than or equal to 10? Is 11 less than or equal to 10? No. Now you are going to go here, and let's say we will just stop the things. We will just stop the program. Okay. When you hit a no, you'll just stop the program. And that's it. We have technically repeated the process, and with a few lines of instructions. I'm going to show you how to code it. But like few lines of instructions and a mechanism with which you can come back to this position again, and your looping process is done. This is the essence of loops. This is how loops works. I hope this point is making sense to everyone. So now we know like how the flow is going to look like, right? Now let's talk about how to code it. How to code a situation like this. So in order to code the situations like these in different programming languages, we have different syntaxes. If I talk about specifically to JavaScript, we can define these looping controls in multiple ways, right? We have multiple ways that we can use in different situations, right? The first way that we have is called as a while loop. The first way that we have is called as a while loop. Okay. So if I just cut this diagram, if I just cut this diagram a bit, copy, paste. Okay. So the while loop is going to have a similar structure. See, we initialized a variable. Why did we initialize a variable? Because inside this variable we are storing the quantity. Every time we are incrementing the quantity and comparing the quantity. So it is good to have it stored somewhere, right? Otherwise we won't be able to increment and compare. If you won't store this value 1 inside I, you won't be able to increment something and compare. You have to somehow use the storage structure of variable, right? So in similar way, you are going to do the same thing in while loop. So you say let I is equals to 0. Okay, a similar basic JavaScript syntax. Now, how while loop looks like? Whenever you have to define this part, this particular part, where you have a condition, you have a set of instructions, and you have incrementing statements that is going to eventually lead you to termination of the loop. You're going to say while everything in small, then inside a pair of parentheses, you put a condition. Okay, and then you initialize a pair of curly braces. Whenever we have a pair of curly braces, we get a block. So this is going to be a while block. Okay. Then you are going to have set of instructions, right? This is like set of instructions, This is your condition, right? And then you are going to write incrementer or decrementer statements. This is your incrementer statement. You can also say updater or updating statement. In simple words, you can also say updating statement. This is how while loops are going to look like. Now you might feel a bit weird. Let me exactly show you with an example. So if I paste the chart again, so if I have to code this whole program, what I will write, I'll say let I equals to 0, sorry, let I equals to 1, while I is less than or equal to 10, I will say console.log I plus equals to 1. And that's it. And that's it. So let's see what happens. Let's see what happens when we write this code. So the first line says let I is equals to 1. That means it is going to make a variable I with a value 1. It is going to initialize a variable I. Then we say while. While means till the time this condition is true. So when we say while, it is actually meaning that till the time the condition is true. Till the time the condition is true. So let's see. Is the condition true? Is 1 less than or equal to 10? Is 1 less than or equal to 10? Yes, it is. So we are checking. Is the condition equals to true? Yes. So we are going to go inside the block of while loop. So till the time condition remains true, till the time condition remains true, we will again and again execute the while block. We can again and again, or we will again and again execute the while block. So see, is the value 1 less than or equal to 10? Is 1 less than or equal to 10? Yes. So you go inside the while loop block. It says console.log I. So you print I. So let's say you print 1. And then you increment the value of I plus equals to 1. So I was 1. 1 plus 1 becomes 2. So I actually becomes 2. Okay. The moment you do this, then if you remember this instruction where you go back again, so technically, if let's say you have some instructions later, you are not going to execute them. The moment you do I plus equals to 1, you go back again to the while loop. You go back again to the while loop and ask, is the value of I less than or equal to 10? Is 2 less than or equal to 10? We say yes. 2 is less than or equal to 10. So you go inside the while loop again. You say console.log I. So I is 2. So you print 2. Okay. And then you increment I again. You increment I to 3. Okay. Now, the moment you increment I to 3, you are again going to go back to the while loop. You're not going to move further. You're not going to move further. You're going to go back again to the while loop. Is the value of I, which is 3, less than or equal to 10? Is 3 less than or equal to 10? Yes. 3 is less than or equal to 10. So you go inside the while loop block and you print 3. And you print 3. And then you move ahead with I plus equals to 1. I becomes 4. And then you again go back to the while loop. You are not going to move further. For example, if let's say we have say console.log end here. Something like this, right? After this curly brace of the while loop, we have console.log end. We are not going to execute it. Instead, we are going to go back. We are going to go back to this while loop, right? This is going to be the process of execution. So let me repeat again. Let me repeat again. So how we are going to code a while loop and how is it is exactly going to execute. Let's see. So let's keep the basics in our mind, how the while loop looks like. You write the keyword while. Inside the parenthesis, you put a condition. Till the time condition is true. Till the time condition remains true, we again and again execute the while block. So this is the while block. Everything inside this is the while block. Inside this while block, you are going to have the set of instructions that you want to execute and the updating situation also, the updating statement also. So let's see. We say let I is equals to 1. So we initialize a variable I is equals to 1. Okay, let's remove this. Now, we go to this line. While I is less than or equal to 10. Is I less than or equal to 10? Is 1 less than or equal to 10? Is 1 less than or equal to 10? Yes, it is. If it is yes, that means this condition is true. Condition is true, right? This condition is true. And when the condition is true, you execute the while block. This is the while block. So the while block says console.log I plus equals to 1. So print I printed I, and then I increment I will become 2. I becomes 2. Okay. Now you can see we have executed the last statement of the while block. We will not execute this console.log because currently the while loop is still going on. Until or unless this condition becomes false, we are not going to exit the while block. So the moment you do I plus equals to 1, you are going to go back to the while loop. You will not execute this statement. You will not execute this statement. Instead, you will go back to the while loop and you say, is 2 less than or equal to 10? Is the value 2 less than or equal to 10? Yes, it is. So the condition is true again. This condition is true again. If the condition is true, you again and again execute the while block. So I will again execute the while block. The first line says print I. What is I? 2. So I print I, and I do I plus equals to 1. That means I increment I to 3. And again we go back to the while loop. And again we go back to the while loop. We are not going to execute this console.log end. We are again going to go back to the while loop. So every time, if the condition is true, you execute the while loops block. When the block execution is done, you again go back to the checking the condition. It's like doing if again and again. The if conditional again and again. Something like that. Right. So again, while 3 is less than or equal to 10. Is 3 less than or equal to 10? Yes. So you again execute. You print 3. You print 3 and you increment 3 by 1. So 3 becomes 4. I becomes 4. And you are going to go back to the while loop again. You're going to go back to the while loop again. Right. Again, still this statement is not executed. Console.log is not executed. You go back to the while loop again. Is 4 less than or equal to 10? Is 4 less than or equal to 10? Yes, it is. So let's print 4. See, the first statement is print 4 and increment I by 1. I becomes 5 and so on and so forth and so on and so forth. Right. I will keep on incrementing itself. Let's say I becomes 9. The moment I becomes 9, you check. Is 9 less than or equal to 10? Yes, it is. You print 9. You print 9. And then you increment I by 1. So I becomes 10. You go back again. Is 10 less than or equal to 10? Is 10 less than or equal to 10? Yes. So you print 10. You print 10. And you increment I by 1. I becomes 11. Moment of truth now. You go back here again. Is the value of I, which is 11, less than or equal to 10? Is the value of I 11 less than or equal to 10? No. The moment you say a no, this while loop stops. The moment while loop stops, we are going to come here. When while loop stops. So when the while loop stops, you are going to go to the next line of the while block. So here the while block ends, end of the while block. You are going to execute the next line of the while block. Right. This is how things are going to work. And see, with like 1, 2, 3, 4, 5. With 5 lines of code, we are able to print everything from 1 to 10. Now the best part is, if let's say you want to print everything from 1 to 10 raised to the power 5, you have to just put 10 raised to the power 5, 10 raised to the power 6, whatever value you want. And the same piece of code is going to help you to print everything from 1 to 10 raised to the power 5, 1 to 10 raised to the power 6, 1 to 10 raised to the power 3, anything. So with a few lines of code, we have repeated a task. We have added the essence of repetition, where the essence of repetition was print a value and go to the next value and then check again. This is how while loops work. And now we are going to see it actually in the coding implementation on VS Code. We are going to write a code in VS Code for this, and we will see this while loop in action. So before we actually start the coding implementation, a fair question to ask is, what is the difference between while and if? Okay. The only most basic difference is, if will check your condition only once. Doesn't matter if the condition is true or false, it will only check the condition once. Okay. If will only check the condition once. Doesn't matter if the condition is true or false, it will only check it once. Whereas for a while loop, it will check your condition again if the last time if the condition was true. it will execute the block and check the condition again. It will check the condition again. It will check the condition again. So the difference is while loop checks your conditions again and again till the time it becomes it becomes false. The condition till the time the condition becomes false, till that time it is going to again and again keep on checking. So if instead of while, if I put a if here, it will see I is equals to 1. Is 1 less than equal to 10? Yes. It will print 1, increment I to 2, and that's it. Because if will only check your condition once and execute everything only once. Doesn't matter if the condition was true or false. But because you have written a while, it will again check the condition immediately once the while loop block ends. It will again check the condition. If the condition is true, it executes. Then again check the condition, executes. Again check the condition, executes, till the time the condition becomes false. The first time the condition becomes false, the while loop block will not be executed and the line next to the while loop will be executed. This is the basic difference between while and if keywords. You might get a question in your mind that why we are always doing I plus equals to 1. The problem is if this I plus equals to 1 is actually changing the value of I. Let's say if I don't change the value of I, let's say this statement is not present here. If you don't change the value of I, your condition is never going to change because I is 1. Is 1 less than equal to 10? Yes, you print 1. Then you again go back. Is 1 less than equal to 10? Yes, you print 1. You go back. Is 1 less than equal to 10? Yes, print, and so on and so forth. If you won't be having this I plus equal to 1 or similar updating statements that can change the state of the variable, if you will not change the state of the variable, the condition will not change. And it is mandatory that condition should always change because otherwise this while loop is gonna go infinite. And that is not something that we want. That is why we need to write an updating statement. This updating statement can be anything: plus equals to 1, plus equals to 2, plus equals to 10, minus equals to 1. Depending on question to question, we are going to think about it and then implement the updating statement. So let's try to code our first while loop. Okay. So we'll say while demo1.js. Okay. And let's say we say let I is equals to 1. What is this statement doing? Initializing a variable using which we will loop. Then we say while I is less than or equal to 10. So this is checking condition till the time, or checking condition again and again till the time it becomes false. Wait, till the time it becomes false. What do? You say console.log I and I plus equals to 1. At last, let's say we say console.log end of program. Okay, end of program. Cool. If in my system you can see this less than equal to sign is a bit different. This is due to a font. So if at any point of time you are confusing with it, in your computer you have to just press the less than and then press equals to. This will be equivalent to this less than equal to that I am having in my system. This is due to the difference in font. Okay, so this is the program. Let's run it. If you run it, then you can see 1 2 3 4 5 6 7 8 9 10 and end of program and end of program. Now this code might be clear to you, but there is a very interesting tool inside VS Code. How to use it, I'm going to teach you later, but let me use it and show you line by line execution of the code. It's very interesting. It's called as like this is the process of debugging the code. That is, we are going to go line by line and check what the code is actually going to do. Right, I'll teach you later that how you can also do it in your system, but for the timing, let me show you. So okay, so let's see. Okay, so currently what you can see here is The code is at line number 1. You can see the highlighted part. The code is at line number 1. At line number 1, we initialized a variable I. So you can see a variable I has been initialized. Right, variable I has been initialized. There are a lot of other things also. Exports, module require. You don't need to know about this for the time being. So you can see I variable has been initialized. Now you are on line number 2. On line number 2, it is checking. Is I less than equal to 10? Is 1 less than or equal to 10? Yes, it is. So you see, it went inside the block of while. And we are on line number 3. We will print I. So see, it printed I here. And now we are going to increment I by 1. So I was 1 already. If we increment 1 by 1, see, I became 2. I became 2. Right? Now, is 2 less than or equal to 10? Yes. So again, the condition is true. You went inside the while loop. You print 2 and you increment from 2. Now I became 3. Can you see I became 3? Is 3 less than equal to 10? Yes. You again go inside. You print I. What is I? I is 3. So you print 3. See, we got printed 3. Now we are on line number 4. We again want to increment I by 1. So 3 plus 1 will become 4. Have a look here. I will become 4 now. See, I became 4. Now is 4 less than equal to 10? Yes. It will go on like this. It will go on like this. It will go on like this. It is 8 now. We'll print 8. Go to 9. Is 9 less than equal to 10? Yes. We print 9. Now 9 plus 1 will become 10. Is 10 less than equal to 10? Yes. And we print 10 and we increment I by 1, that is 11. You see, I became 11. Now, is 11 less than or equal to 10? This is the condition that we have to check and we have to think about it. Is 11 less than or equal to 10? No. And when the condition is false, the while loop condition is false, we are not going to go inside the block of while. Instead, we are going to exit out of the while loop and execute the next statement out of the while loop. So if you see, the moment I press this button step over, you can see we didn't go inside the while loop. We just came outside and we are going to execute line number 7, which says end of program. And that's it. Your program has been done. This is completed. So this was the step-by-step, I would say, execution of this while loop. And this is how actually you can repeat some tasks. So see, with so small amount of code, we are able to do this. Now the best part is if I want to print 100 numbers now, all I can do is just change this value to 100 and everything is going to work till 100. So now you can see I'm able to print up till 100. So this is the essence of loops, and this is how you can actually write your own loop as well. So I hope the coding implementation of the while loop is clear to everyone. So with the basic knowledge of while loop, let's try to learn one more program. Let's try to write one more program and see how we can do this whole story of repetition. So the program says, or the question says that, write a program to calculate sum of all the numbers from 1 to 10. Write a program to calculate all the numbers from 1 to 10. Now, if I have to add all of the numbers, what I can do? I can do something like, let's say I will build a variable answer. And in the answer, I will manually write 1 plus 2 plus 3 plus 4, so on and so forth, plus 10. I have to manually write all of this up till 10. It still makes sense. But let's say if I ask you to give me the sum of all the numbers from 1 to 10 raised to the power 5. So you have to manually add everything to 10 raised to power 5. It will be a lot of tasks, right? But we can do something relatively simple. So let's try to decipher the process, what we actually have to do. So let's say we will initialize a variable answer is equals to 0. Inside the variable answer, I'm going to store my final answer, and variable I equals to 0. So I will be having two variables with me. Okay. I'll take a decision. Is I less than or equal to 10? Yes or a no. Okay. Yes or a no. If the value of I is less than 10, if the value of I, so I starts with 1, let's say. If the value of I is less than or equal to 10, I want to add this value, right? If I becomes 11, then I don't want to add it in our answer. But if the value of I is less than or equal to 10, if the value of I is less than, I want to add it. So how do I add it? I can say sum plus equals to I. Sum plus equals to I. Okay. Now once I have added it, like I've added, let's say the first value 1, then what do I want to do? I want to go to 2. So how about we increment I to 2. So we add one more value to I, and then we repeat, and then we repeat. So I becomes 2. Is 2 less than or equal to 10? Yes. So I add 2 to my sum. Then I becomes 3. Then I go back. Is 3 less than or equal to 10? Yes. I add 3 to my sum, and so on and so forth. When I becomes 11, is 11 less than or equal to 10? No. 11 is not less than or equal to 10. So I will say console.log answer. Console.log answer. Can I say that? Right? Simple thing, right? What is the element of repetition here? What is the element of repetition? The element of repetition is add the current value and move to next value. Add the current value and move to the next value. Add the current value and move to the next value. So see, we are adding the current value and then we are moving to the next value and then we are repeating. So how we will write this code? We will say let I is equals to 1, let answer is equals to 0. Why are we initializing answer with 0? Because initially we have not added anything. So the answer should be 0, right? If we will initialize answer with something else, then it will put some bad effect on the final answer. And then we say while I is less than or equal to 10, we say answer plus equals to I plus equals to 1. And finally we write console.log answer, because in the answer variable we have the final value. Can I say that? And let me just write this code as it is. See, same thing we are going to do again. While demo2.js, let I is equals to 1, let answer is equals to 0. While I is less than or equal to 10, answer plus equals to I plus equals to 1. Console.log answer, and that's it. If you run it, we are getting the value as 55, and that is the correct answer. The sum of the first 10 natural numbers from 1 to 10 is 55. So see, I don't have to manually calculate it, right? I can just write a basic loop. Now let's say if I ask you to sum up the first 100 values, all you have to do is just change the condition up till 100 and you will immediately get the answer as 5050. As simple as that, right? So this is again the same thing. We have done almost the same thing. What we do, we initialize some variables, we put a condition, we put our actual statements, and we put an updater statement to actually change the variable values, because if the variables that are involved in the condition are not going to change, the condition will never stop, because it's not changing, so it will not stop. So we have to somehow make things stop, and if you want to make things stop, you have to write this updating statement. You keep on doing this. Once we are done with this, we can move ahead and maybe print the answer, right? So if I just summarize or repeat everything once more, we wanted to calculate the sum of all the numbers from 1 to 10. And just one basic note, you can write the same code in different ways. As I said, correct answer can be written in multiple ways. In your initial days of programming, it's important for you to know at least one good way to go for. So we want to calculate the sum of all the numbers from 1 to 10. In the last question, I told you how you can print the numbers from 1 to 10. I told you how to print the numbers from 1 to 10. So technically, you know, right? From 1, then you go to 2, then you go to 3, then you go to 4, then you go to 5. How to move on these numbers, you know, right? Now, instead of just moving and printing, I have to sum it up. So what I'm going to do? Let's say this is going to be answer, my bad. Okay. So what I'm going to say is, let's prepare a variable answer. Let's prepare a variable answer. This variable will actually store the final value, final sum value. Okay. This variable will actually store the final sum value. And this variable I is for the loop. For, or we should write to be used in loop. Okay. This variable I is going to be used in the loop. And then what is the structure of a while loop? You write while, then you write a condition, and you put your statements. So what is the condition? I'm going to start with 1. I want to go from 1 to 10. I can start with 1 and I can say, is 1 less than or equal to 10? Is 1 less than or equal to 10? You will say yes, 1 is less than equal to 10. So 1 should be added to our final answer because we have to calculate the sum of numbers from 1 to 10. So how about I have 1. I don't care about rest of the numbers. I definitely have got 1. Let's at least add 1 to our answer. Once you have added 1 to your answer, so initially answer was equals to 0. Now you added 1 to your answer. So 0 plus 1 becomes 1. And then you increment I. Previously I was 1, now I became 2. I became 2. And then you go back again because remember, right? If the condition was true, you go back again and check the condition again. Is 2 less than or equal to 10? Is 2 less than or equal to 10? Yes. So what do? You add 2 to your answer. What is the value of answer? 1. What will be 1 plus 2? 1 plus 2 will be 3. So answer will become 3. And you can say, right, 1 plus 2 is 3. So answer is showing you 3. So I added 2 to my answer. And now from 2, I want to go to 3. How do you go to 3? You increment I. So I plus equals to 1. 3. And then you move ahead. Is 3 less than or equal to 10? You will check again. Is 3 less than equal to 10? Yes. So you add 3 to your answer. Your answer was 3. 3 plus 3 becomes 6. So answer becomes 6. And now from 3 you want to go to 4. That is I plus equals to 1. So I went to 4. And then you check the condition again because last time the condition was true, right? Is 4 less than equal to 10? Yes. You add 4 here. So 6 plus 4 becomes 10. And then from 4 you want to go to 5. You increment I by 1, it goes to 5 and so on and so forth. And you can even see this same kind of, I would say, working in VS Code. So let me debug it again. So you can see I have 2 variables, answer and I. See, answer and I are 2 variables. Initially answer is 0. I is 1. Is 1 less than equal to 10? Yes. So you add 1 to your answer. So 1 plus 0 becomes 1. Answer becomes 1. And then you increment I by 1. I becomes 2. Is 2 less than equal to 10? Yes. So you add 2 to your answer. So 2 plus 1 becomes 3. It comes to 3. And then you increment I by 1. Then 3 plus 3 is 6. I goes to 4. 4 plus 6 is 10. Answer becomes 10. And you go to 5. And so on and so forth. I is 7. You add 7. Then I becomes 8. You add 8. I becomes 9. You add 9. Is 10 less than equal to 10? Yes. So you add 10. 10 plus 45 is 55. And you move I to 11. Is 11 less than equal to 10? No. So while loop will stop and you actually go out of the while loop and you go to line number 7 and that's it. Okay. This is how things are going to work for this while loop, where we want to calculate the sum of the first 10 numbers, and you can like change the value from 10 to 1000, 10,000, 500, anything, and it will calculate the sum up till there. So let's try the discussion on a new question. So the question says that you have to print all the numbers from 20 to 1 in decreasing order using a while loop. So we have already solved a question where from 1 to some number, let's say 10, we were able to print it. Now we have to just reverse the process. How can we reverse the process? So when we wanted to print everything from 1 to 10, we initialized the variable I with 1. And then from 1 I went to 2, then from 2 I went to 3, and so on and so forth. How about this time? If I start a variable with, let's say, a value 20, and from 20 we won't move to 19, from 19 to 18, from 18 to 17, and so on. Something like this if we try to do. So we say, how about if you do I is equals to 20, and then you check, is I greater than or equal to 1? That is, whether the value of I is still greater than or equal to 1 or not. If it says a yes, or it says a no. If it says a yes, you print I, and then you put I plus equals to, sorry, this time from 20 I have to move to 19, from 19 I have to move to 18, from 18 I have to move to 17. That means I have to decrement the value. If I plus equal to 1 can increment the value by 1, how can you decrement the value by 1? Can I say I minus equals to 1? That's it. And we will loop from here. The moment we hit a no, we will go for a stop. We'll stop it. So see, initially I is 20. Initially I is 20, right? Initially I is 20. You check. Is 20 greater than or equal to 1? Yes, it is. So you print I. So you print 20. Once you print 20, you move ahead and you do I minus equal to 1. That is decrement I by 1. So 20 minus 1 is 19. So I becomes 19. And you go back and check the condition again. Is 19 greater than equal to 1? Yes. So you print 19 and you decrement I by 1. So 19 minus 1 is 18. I becomes 18. And you move forward again. Is 18 greater than equal to 1? And so on and so forth. This is going to happen so on and so forth till the time I reaches 1. Is 1 greater than or equal to 1? Yes. So we print 1 and we decrement I by 1. So I becomes from 1 minus 1 to 0. Is 0 greater than or equal to 1? No. So we move here and stop the program. And how can we code it? How can we code it? Very simple. So if I make a new file, while demo3.js, we can select I equals to 20. Now what will be the condition? I should be greater than or equal to 1. We print I and we did I minus equals to 1. And that's it. If you run it, 20, 19, 18, 17, 16 up till 1, everything is getting printed. And the best part is, if I want to print everything from 200 to, let's say, minus 200, I can just change the value 200 here and change the value to minus 200 here, and things will work again, like same loop will work. So you can see I'm starting from 200, I'm decrementing, and I'm moving till minus 200. So whatever you want to do, whatever variation you want to do, you can do it here. This is going to be the simple coding implementation for this, right? So this is how, like, in different ways you can write while loops. This is how you, in different ways you can write while loops, right? So while loops are one way of achieving looping. I told you, right? In JavaScript you can have multiple ways. The second way to achieve the looping is for loops. Let's talk about the second way. And to be very honest, second way is absolutely same as while loop, just a change here and there. So let's say if I write a code, let I is equals to 1, while I is less than or equal to 10, I plus equals to 1, and above it console.log I. Let's say this is the while loop. If I want to just, like, if I have deciphered the logic and I want to code it, Like the logic is going to be same, because this flowchart actually shows every type of looping structure. It's just now we are going to discuss the syntax. If you want to actually just convert it to a for loop, let me copy all of this. Okay, so let it just see how I am converting it to a for loop. Okay, so what I have to do is I will write the keyword for. You will write the keyword for, and you put a pair of parentheses. In the pair of parentheses, inside the pair of parentheses, you will first write your initializing statement, where you are initializing the value using which you will loop. Then you have to, one second, let me cut it from here. Then you have to put the condition. You have to see, from here I'm cutting it and just pasting it here. You have to put the condition, that what is the terminating condition, which condition will become false when you have to stop the loop. Then you put again a semicolon. See, you put a semicolon here after the initializer, then you put the condition and then a semicolon, and then whatever is your updater statement, you write the updater statement here. Once again, you write the updater statement here. See, what did I do? I put this placement here, this one here, and this one here, all separated by semicolons. We will initialize a pair of curly braces. This is going to be a block of for loop. And then whatever is your internal logic, I'm going to put that internal logic here. And this is how we can convert a for loop into a while loop into a for loop. As simple as that. So I know a lot of things I told you. Let me talk about it. So for loops are one more way to do same thing as of while loop. There is no particular advantage. There is no particular advantage of using a particular loop. There is no particular advantage of using a particular loop. You can use a while loop or you can use a for loop. Both of them are present. None of them have got any disadvantage or any advantage. You can use anything that you want. It's like you have been given two options to do the same thing. You can use anything. There is no harm in choosing one or not choosing the other. In for loops, the difference with while loops is only of syntax. If you talk about the syntax, then inside the while loop, the syntax looks like you write while condition, then here you write the logic, and then you write updater statement, and before all of this you write variable initializer. Whereas in for loop, you write a for, and inside the parenthesis you put this and this, all of these three statements together separated by a semicolon. So you write variable initializer, then you put a semicolon, then you put a condition, then you put a semicolon, then you put updater statement, and that's it. You close the parenthesis, and then you open the block of for and write your logic. That's it. Apart from that, everything is same, like the same looping structure, everything. Like you have to put a condition. This is where you put the condition. You initialize a variable. This is where you initialize. Updating, internal logic. I hope this point is making sense. So if I try to code for loop in front of you, let's say for demo1.js, right? So program to print numbers from 1 to 10 using for loop. So you can say for let I equals to 1, I less than equal to 10, I plus plus, console.log I. That's it. Everything same, just rearrange the statements, and you can see everything is getting printed from 1 to 10, right? If I want to do the for demo 2, that is sum of the first 10 numbers, you can say let answer is equals to 0. For let I equals to 1, I less than equals to 10, I plus plus, answer plus equals to I, console.log answer. If you run it, see answer is coming as 55. So let me show you both of the codes. See, in both of the files, I have written both of the codes and it looks so similar to like the while loop, right? So I can maybe try to have one more window. And let me have one more window once again so that I can compare. Uh, New window. Okay, so it only opens like this. Do I have another text editor? Sublime. No. So let me open this in terminal instead. I can do one second. So I'm going to show you your while code here. Okay. So I can say cat while demo1.js. You can see your while loop code is here. And let me open one more while loop code. That I can open here. Okay, now you can compare. Now you don't need to open like this, but I would just want you to compare uh, that this was the while loop that we converted to the for loop, right? And this was the while loop that we converted to the for loop. So you can take a look at both and actually compare yourself, right? This is actually how you can convert a basic while loop to a for loop. Everything remains same, just the syntax changes. Now one very interesting thing is I have written one I plus plus here, whereas in while loop I was doing I plus equals to 1. So technically you can do I plus equals to 1 also. I plus equals to 1, I plus equals to 1. It will work as same thing. In the later set of sections I'm going to talk about I plus plus also. So if you run it, still you get the same answer 55. If you run this code, you will still get 1 to 10 output. So I plus equals to 1 still works here. No issues on that part. Okay. So there is a syntactical sugar that exists, that inside a block, if you just have got one line, then you can even avoid curly braces. You can even remove the curly braces and still everything will work as it is, right? But if you have more than one lines, then you cannot avoid the curly braces. So generally for cleaner understanding, we write both the curly braces, and even if we have one line, then also at least I put both curly braces and then only write the code. It just gives a like contextual segregation between each block. Okay, this question is also very simple, right? You can solve it in multiple ways. Like we already know how to print something from 1 to 10 or 1 to 20, right? We already know that. How can we print it? We can say for let I equals to 1, I less than equal to 25, I plus plus, and then we can say console.log I. Can I say with this piece of code, with this piece of code, I will be able to print everything from 1 to 25. As simple as that. But in this question, there is a new question that is in front of you now. You have to write a program to print all even numbers greater than 1 and less than 25. Even numbers means which are completely divisible by 2. So technically you don't have to print everything from 1 to 25. You have to only print that value which is an even number, which is an even number. So technically you have to only print those values of I which are even, that qualify as a valid even. So I don't have to print I every time. That means I have to take a decision that should I print I or should I not print I? How can you take a decision? We can use conditionals. So we can say if I mod 2 is equals to 0, we all know that how can we put conditionals, right? And we will bind it inside a if check. Now let's see what happens. I starts with 1. Is 1 mod 2 equals to 0? Is 1 mod 2 equals to 0? No. So we are not going to execute this if check. And there is no else. We have not put any else, so nothing will be executed. This if check won't be executed. And you move back to the for loop and you do I plus plus. I becomes 2. Now, is 2 mod 2 equals to 0? Yes, because 2 is an even number. Now you can print 2. So we will print 2. And then you move ahead because there is nothing else. I do I plus plus. I move to 3. Is 3 mod 2 equals to 0? No. So this whole if check won't be executed. And we just go back to the for loop and so on and so forth. That is the same code using which we printed everything from 1 to 25. It's just that instead of just directly printing everything, let's take a decision before we actually print anything. So that decision we can take using if. So this can be one way to code this question. For loop or for demo3.js. I is equals to 1, I less than equal to 25, I plus plus. Check if I is even. So we'll say if I mod 2 is 0, then only print I console.log I. Otherwise, don't do anything. If you run it, see 2, 4, 6, 8, 10, 12, up till 24. This is one way to do it. This is one way to do it. And technically, there is one more way in which we can do it. How about if I start I with 2, if I start I, because I know I have to print everything from 1 to 25. How about if I start I with 2, if I start I with 2 and just print I console.log I, right? Console.log I, and then instead of incrementing I by 1, how about I increment I by 2? And here we can put a condition. Let me put it properly. We can say is I less than or equal to 25. Okay, so let's see. Either this will be a yes or it will be a no. When it will be a no, we will stop. Okay, cool. So I starts with 2. I starts with 2. You check. Is 2 less than equal to 25? Is 2 is less than equal to 25? Yes, it is. You print 2. You print 2. The moment you print 2, you can go forward and increment I by 2. You can increment I by 2. So 2 plus 2 will become 4. So I becomes 4. And then You go back and check again. Is 4 less than or equal to 25? Yes. So you print 4. You print 4. The moment you print 4, after it, you will say 4 plus equals to 2. Like you will add 2 to 4. That will become 6. It becomes 6. You check again. Is 6 less than or equal to 25? Yes. You print 6 again, and so on and so forth. At last you will reach 24. Is 24 less than or equal to 25? Yes. You print 24, and then you do add 2 to 24. 24 plus 2 becomes 26. And then you move ahead again. Is 26 less than or equal to 25? No. And you stop the program, and that's it. So the same implementation can be done like this. In this time, let's start with 2. And this time, let's do I plus equals to 2. Here also, let's do I plus equals to 1. Okay. I plus equals to 2, console.log I. And that's it. And that's it. See, same output. So there can be different ways to solve the same question. Both of the ways are equally efficient. It's not like one way is less efficient, one way is more efficient. If you see, like later we'll discuss about how you actually calculate the efficiency of a code. If you see in that terms, everything is absolutely fine. You don't have to actually care about it. So in different ways, we can solve the same question. That is the essence of programming. And I hope you got the logic for loops.